Alright, so normal distribution. Okay, so these are 99% on the paper 2. Okay, because you will be using your calculators. So you do need your calculators out for this, because we will be practicing using them. I've tried to screenshot the pictures that you're going to be using, and the screens that you're going to be using, so it should be useful. Now, what do I mean by normal distribution? Well, if things are normally distributed, are you familiar with that? Okay, it means that the data would fit this kind of curve. This is known as the bell-shaped curve. And what happens is that even things like your results, the grades the grade boundaries are pretty much determined by making sure that the results are in a bell-shaped curve. So the majority of people will be getting between a 4 and a 5. These are your 3s, 2s, 1s. These are your 6s and 7s. So that's how they decide where their grade boundaries are. So once they've got all the results in, they try and make sure that they fit this bell-shaped curve. Okay? Wrong page. We are always interested in the mean, which is allocated this. I always think it's an M. Loads of other people think it's a U. So I think it's an M like that. Okay, so that's the mean. So we're used to seeing the mean as X bar, yes? But this is going to be this one. And standard deviation, we should be familiar with that. That's sigma. Okay? So for these kinds of questions, you need to establish those 2 pieces of information, the mean and the standard deviation. As information for you, so the mean is going to be in the center of our bell-shaped curve. Some of the data is to the left, half the data is to the left, half the data is to the right. Okay? This is all about probability. Okay, so we're talking about probability of events happening. You will be, sometimes they will just write at the top of a question something that looks like this. Okay? Do you remember when we were looking at the binomial distribution, we had something that was really similar to this? And it had X and then there was a B here. This one is an N because it's normally distributed. Okay, so look out for the N. They won't have the mean and the standard deviation, or what, apologise, this isn't the standard deviation, is it? What is this? Variance, because it's a standard deviation squared, okay? So they won't have that, they will actually have numbers there, okay? So they would probably write 5, 2 squared, okay? So you will see what the values are, but know that the first number will be your mean, the second number is your standard deviation, okay? So they will either write it as something squared, or they might write 5, 2. All right, so just know that you're not expected to know which one it is unless they've actually stated the variance is or the standard deviation is. Everyone with me so far? I'm not confusing you. Are you? Okay. No, you don't have to learn this. Okay? No, you don't have to learn this. If this is our mean in the middle, the mean value, whatever the mean value, plus one lot of standard deviation, whatever it might be, covers 34% of the data. So in other words, if our mean was 5 and our standard deviation was 2, this would be 7, yes? So that means between 5 and 7, 34.13% of our data is going to be sitting in there. Okay, so if we got, they said what's the probability that something's between those two, you'd say 34.13. Okay? Equally, these are really rubbish numbers. Anyway, between 5 and 3, same situation, okay, because it's symmetrical. Between 5 and 9, okay, because that's 2 standard deviations, we've got another 13.59. So all of this together would be our probability. I can't do that off the top of my head. Okay? Basically, within 3 standard deviations away from the mean, pretty much 100% of your data is taken into account. And I think it's officially 99% or 99 point something. But essentially, you want to think of this as being 50%, this as being 50%. Okay? And it's going to be within 3 standard deviations. Now, as I say, you don't need to learn that, but you just need to, you may want to be kind of familiar that of the basic numbers. No, let's not bother. That's too hard. Okay. I was going to take it out because I'm thinking, why is it really that important? But I kept it in just for interest's sake. So essentially what all this does is to show you that the normal distribution curve would change depending on your standard deviation value. Okay? So this 0.3 is a small standard deviation. Okay? And that's why that curve goes up high and peaks down here. Okay, so it's a really tall and narrow one because my standard deviation is small. As your standard deviation gets bigger and bigger, that's when the bell-shaped curve stretches out. Okay, again, not important, but I thought it was interesting. Maybe looking at lots of places, that's not hard stuff. Okay, anyway. We need to remember that the total area has to add up to 1, okay, or 100%, so that's an important feature, but we know that about probability anyway. Right, so what do we have to do? In some cases, now, going back a few years, these kinds of questions were often found on a non-calc paper. The reason that it's pretty much now always on the calc paper is that they've removed some of the information from the formula booklet. You used to have to look up stuff in the table. So they've taken that out, which means that you can, a lot of this information is not as relevant as it used to. Or they try and word questions in such a way that they're encouraging you to use this formula when you wouldn't have needed to in the past. I'm rambling. Basically, standardized normal distribution is where you've taken data and you've rehashed it to be able to compare it. It's like having percentages. So say one test was at 40, another test was at 63. You want to compare how well you did when you change them both to be percentages. What this does is, if this mean was 5 and this mean was 14.3, this standard deviation was 7, this standard deviation was 0.4, we want to be able to compare them, okay? And it's not so easy, as you can see, when we've got different values to do the graphs different. So we find a standardized normal variable. So this is how we change it. Yep. I can't hear a word you said. What's that? The coefficient of variation. Oh, maybe. Sorry.
No, I think it's standard deviation divided by the rate. So, anyway,
Right. So what it does is it standardizes it so that it pretends that everything has a mean of 0 and a standard deviation of 1. Okay. So your original data has been altered to be able to compare it, and we're assuming or pretending that both have a mean of 0 and a standard deviation of 1. Okay? If that's the case, so if something has been standardized, you will see this letter here. It's called Z. So we are changing our values to be a Z score. Okay? So, the easiest thing is to start looking at some questions to know what on earth I'm rambling on about. Okay? Let's go. Alright? Yeah. Oh, you don't know which question we're attached to.
it's on the other page, bottom.
Oh, is it bottom? Save. Alright, here we go. So we're trying to find the probability of Z, so we know, as soon as we've seen Z, we know that our mean is 0 and our standard deviation is 1. Okay, so we know that information because we saw Z. We're trying to find the probability that Z is less than 0.56. So, what I would like you to get into the habit of doing is sketching, and I mean sketch, I do not mean take 25 minutes drawing a normal distribution. You sketch a curve, okay? If you want practice, draw it next to it. Literally, you're just doing that. Oh, you're doing that. Because it's a Z, you're going to write 0 in the middle, okay? Because that's where your mean is. We're looking at Z being less than 0.56. So think about this. If this is 0, 0.56 is on which side of that line?
Right.
On the right, yes? So we don't care at all how far away it is. We're going to write 0.56 because we know it's on the right. We want the probability that Z is less than that. So we're talking this probability here. We understand what we're finding, yeah? Now, can anyone tell me anything about the answer that we're going to get? More than, less than, we know it's going to be roughly, anything. Can anyone tell me anything about the probability we're going to, what the answer we're going to get?
A lot.
A lot? Why a lot? What do you mean a lot?
Because isn't that like 80% of the curve?
So we're not 100% sure where 0.56 should have been, but, so Leah, you randomly said 80%.
More than half.
This is what I was looking for, okay? We know that our answer has got to be more than half. Like, we may have drawn this in completely the wrong place, but we know it's more than 50%. So they're the kinds of things that when we're doing these questions, I need you to keep an eye on, okay? Because if you've typed in the wrong value into your calculator, it's going to spew up an answer that you should recognize if it's right or wrong, okay? I'm not saying you're going to learn all these numbers, but I want you to always be aware, is that sensible given the diagram we've just drawn, okay? Right, so, let's go into using the calcs. Alright, so, in the GDCs, you need to have a document open. And when you hit menu, this should come up. And you're going to go down to probability. And then hit across, and you'll come up with 5 options. Okay? You're going to go down to the distributions one. Okay? So I know factorial is highlighted, but it's just because I had to screenshot it there, otherwise you couldn't see what was going on. So you're going down to distributions, and then notice here it says normal CDF. Okay? This is very similar to the binomial stuff, in that the C is taking us, we're looking at the area, up to and including the value we're interested in. What value are we interested in?
0.5.
0.56, yes? So, when you hit normal CDF, you get this screen here. It defaults to being negative infinity. Okay, because they're saying that way down here is negative infinity. Okay, so you can leave that as your lower bound. And so all we need to enter is our upper bound as being 0.56.
Mine doesn't say negative infinity. It says mine is 9E999.
And mine's
Oh, you should be fine then, because that's way negative anyway.
Okay.
That's why it doesn't know. Basically, you just need negative 100 would be enough. Okay, as long as you've got a negative value here, you're fine. It should also default to 0 and 1, does it?
Yeah.
Yeah? So you've got your mean is 0, you've got your standard deviation 1. Hit OK.
0.712.
Pardon?
0.712, so 71.
1, 2. Okay. What do we always round to? 316. Yeah? Are we happy with that? Yeah?
That's not the answer.
Yeah, that's it. That's all we have to do. Is that more than half? What's half? Total's 1. We said more than half. Satisfies that at least. So, and this is what I mean. You're not going to know whether it's right or wrong. You're not going to know for sure, but at least it's in the right track. Okay, so you know that you're on the right track.
Because the other ones were in percent.
But oh right. So now, if they've said what percentage, then obviously you would then change that to be 71.2%. Okay, totally fine. But generally, our answers, your calculator will always give you the decimal point. Okay, we're on Z scores still, all of these. Okay, so I've drawn you a little sketch. This time we want Z to be greater than negative 1.23. Which side of the line is negative 1.23? Left. Okay, again, doesn't matter where. We want it greater than.
So would that still be our upper bound?
Right, so this, you should have two different options, okay? Now, what you could do is if you want to keep your calculator default to be negative infinity, you could find this
Subtracted from
probability, yes? So you could find the red part and you could do 1 subtract the red, yes? Because we know that everything on the right would add up to that. Or you can change your lower bound to be negative 1.23, and then you can put just a big number into your upper bound. It doesn't matter what it is. I don't know how to get the infinity sign, but you can use infinity if you can find it. Okay, so that's the answer we got. Again, you want to say to yourself, does it make sense given the amount of the graph we're shaping? Yes, it does. Okay? Oh, that's awesome. Less than negative 0.86. So which side of the line is negative 0.86? It's on the left. As you can see, I often draw my lines in the same place. It doesn't matter to me where they are. Just have I got it on the correct side? And we're talking less than, so we're talking about this bit here. So we're not talking a big number. We know it's going to be less than a half or less than 0.5.
And 0.805.
Oh, something's gone wrong here. Why do I know that's wrong?
Because it's too big.
Yeah. So what did you put as your lower bound?
That line probably.
Oh, remember we want the left-hand side of it. So your lower bound is going to be negative infinity or negative 1,000.
0.19.
You with me?
0.195.
Is that what you said, Leah?
I said 4, but yeah, I didn't round it.
Yeah. Good.
Smoother side.
Okay, so here your lower bound is going to be at negative 1,000 or negative infinity. Your upper bound is going to be negative 0.86 because we're wanting Z is less than that. Okay, so that's why having the sketch is the idea of it is that it's supposed to get you that visual as to how much you're actually looking for and where your lower and upper bounds would be. This one, they want the probability between 0.4 and 1.83. So we need to find those values. They're actually both on the right-hand side, so that's 0.4 and 1.83, and we want them between there.
So do you find one, find the other?
Well, you could do, but the fact that they're all on the calculator, and the calculators as they are now, you can literally just have your lower bound and your upper bound. Okay, so you just stick 0.4 as your lower bound, 1.83 as your upper bound.
Zero point one. Sorry. 0.31.
311. So in the past, often the way that the calculators were set up is that you would have had to found the probability of the 1.83, the probability of the 0.4, and subtracted one from the other, okay? But now you don't need to do that. You've literally got your lower bound, your upper bound, and you're good to go, okay? So a a lot of the time we don't need to change them to Z scores, as I said. And so if you see a Z, that's when you want to be changing any values. I'll see if I can find some questions where you need to use that formula at some point. Just bear with me, but let's have a go at some of these to start with. So here we go. As I said, sometimes they will have lots of words involved, sometimes they will just have something like this. Okay? So they've said the random variable x, and here the n tells us we know it's normally distributed. So what's our standard deviation, what's our mean from this? 10. And our standard deviation is, careful, 2. Yes? Because the squared is just there. So remember, it's either written as the standard deviation squared or the standard deviation is on its own. Okay, so if you see the squared, that's just your standard deviation. They want to know the probability between 9.1 and 10.3. So in this case, no longer are you going to do a sketch with 0 in the middle. Your value in the middle now is going to be a 10. Okay, so that's where this is a fancier one. So our 10 is in the middle. So we want between 9.1 and 10.3. So 9.1, hopefully you will appreciate, is on the left. And 10.3 is on the right. Okay, so we're finding that probability there. Your lower bound is going to be 9.1, your upper bound is going to be 10.3, and this is where we're going to have our mean of 10, standard deviation of 2.
0.01323.
Pardon? 0.233. So I think they're quite nice questions, yes, because it's just chucking stuff in the calculator and making sure that you recognise that it's normal distribution. Okay, so this is a wordy type. So eggs laid by chicken are known to have a mass normally distributed. So as soon as you see that, you're like, right, more normal distribution. Mean 55 grams, standard deviation 2.5. So mean 55, standard deviation 2.5. What's the probability that an egg weighs more than 59 grams? Okay, I've got 3 diagrams. Okay, so our first diagram, our mean is 55. We want to know that an egg weighs more than 59. So 59 sits on which side of that line?
Right.
Okay, so 59. And we want to more than 59. So which side are we going to shade?
Right.
The right, yeah? What do we know about the probability? Answer is going to be,
More than half.
be careful,
Less than half.
less than a half, yes? Because we want more than, and it's just this portion here, yeah? Yeah?
Mm-hmm.
Lower bound is going to be 59. Upper bound. Can you get can you do the infinity? Can you find infinity? Does it work? Let's. I don't
I think
know.
you just have to do 1 minus whatever it is.
Well, let's try it. Or you can put you can put as big a number as you could possibly get excited about.
Well, I got 0.05.
Did you have 55 and 2.5? What did you get?
0.05.
I need another digit.
Oh, damn, 0.04.
Did you mean 5.8?
548.
Did everyone get that? Yeah? And we all use different upper bounds? Yeah. So as you can see, now just be careful though, so the reason I say chuck as big a number as you can in there is that obviously as data changes, so as our values are getting bigger, we need to be careful not to use a small number. So if you use just 80 as your upper bound, that's not going to be big enough, okay? Because we need to imagine that it's way, way, way over here. All right, so just be careful the values that you're putting in. And B, an egg is smaller than 53 grams. Okay, same diagram, or similar diagram. Mean of 55, we want 53, so it's on the left, and we want it to be less than 53. Zero point what?
2.
Cheers. So lower bound, that's going to be a negative big number. You can see if it lets it. 53 is going to be your upper, mean 55, standard deviation of 2.5. And the last one in this question, again, same diagram, 55, and they want between 52 and 54. So your lower bound is 52, upper bound is 54.
0.23.
230. Yes, it is. Just something to be mindful of. I'll see if I can find some past paper questions. But if, for example, you were told this value is 60 and you were asked to find the probability of something being 62%, okay? Not 62%, a bit of it being 62, okay? So we find this probability here. What about if I was asked about 58? Okay, maybe if I wanted to know this less than 58. Does anyone see anything that we could possibly do? I'm just trying to get what's actually happening in that case. Why did I choose 58?
This is 2 less than 60.
And this value was 2 more than 60, yes? What do we know about this graph? It's symmetrical, yes? So, this portion here has to be equal to this portion here. You happy with that?
Yeah.
Yes? So if we had been told the probability of the 62, yeah, and we'd been asked about this red probability, so less than the 58, we could have found this area by doing whatever probability it was, subtract 0.5. Yes, you were happy with that? Oh, show me, Timbers, it's 11:13.